So the LeetCode problem we are going to solve today is called k closest points to origin. Now we can see that this one is a LeetCode medium problem and also a very well-liked problem on LeetCode. The problem statement is quite straightforward. We are given an array of points that represents points on an XY plane or a graph. And we are also given an integer k. Now we need to return the k closest point to the origin. Now we are also given that what is the mathematical equation to point the distance between any two points, and that is the Euclidean distance formula. So that is x1 minus x2 square plus y1 minus y2 square and square root of the whole thing. So we need to say that, okay, say for an example, if this is the input we are given, we can see that there are a bunch of different points presented to us. Now I have plotted these points on this graph and we need to return the k closest point to the origin. So origin is going to be this point 0, 0. So origin point is always going to be 0, 0, and we need to use the Euclidean formula. So let's say that we are given k is equal to 2. So we need to return that what is the second closest point to the origin. So we can see that in this case, this is going to be the first closest point to the origin, and the second closest point is going to be this one. So we need to return this value 2 and 1 as the answer, as this is the second closest point to the origin. Now in order to calculate the distance between any two points, let's say that we want to calculate this distance between this 1 point and 0 0 point. So the mathematical equation is going to be 0 minus the whatever the x square is, that is x minus 1. So 0 minus minus 1 and the square of this one plus, once again we will take y1 minus y2. So 0 minus this one is 1, so 0 minus 1 and the square of whole thing, and then we are going to do the square root of this whole thing. So that is going to give us this distance. That since in this case we are given k is equal to 2, we need to find the second closest element in order to, and return that as the answer. So in this case the answer is going to be 2 and 1 that we need to return. So that's it. This is the whole thing that what the problem is asking us to solve. So brute force approach is actually quite straightforward. In the brute force approach, what we can do is we can simply start calculating all of these distances that are currently given to us. And then after calculating all of these distances, we will have some random values, because for sure we are not going to get exact values, because we don't know which one is the closest, which one is the farthest. Let's say we find some random values, like let's say that this one is 3, this one is 2, this one is 1. I'm just giving some arbitrary values, okay? So something like these. Then once again amongst these values we will have to find that what is the second closest value. So once again for that we will have to iterate over the given array and find the second closest value. In order to do that, it can still take big of n square time in the worst case scenario. So we will have to do something better. So here now for the optimal solution, I have just put down like every single point denoted as a number, and for that number I have calculated that what is going to be the distance from the origin point for that particular value, and I have marked all of these values over here. Now say for an example, just for understanding's per sake, we will try to now understand that this one as if it does not contain a square root. Okay, this is just going to help us understand that what the solution is look like and how we can use max heap in this case to solve the problem. The idea is that we are going to create a max heap of size k, and inside the max heap we will always try to first add the value inside the max heap, and the moment we realize that the size is actually greater than k, then we will have to pull the lastly added element outside of the max heap. Okay, we are only going to store the k values. So in this case we are trying to find the second closest point to the origin. So k is equal to 2. So let's say let's quickly initialize our max heap, and inside the max heap currently we don't have anything. Now in the max heap we are only going to store 2 elements. Okay, I'm just adding one more element over here, because this is we will put down the buffer value to see if we exceed the size of the max heap. If we exceed, we are going to pop this element out. Okay, so now let's try to populate our max heap with the theory we just mentioned. So first we have value number 7, so we are going to put value number 7. Then we have once again value number 7, so we are going to put value number 7. Once again we have value number 2, so once again we will have to adjust the input. So it's going to be 7 and then 7 and then 2, but we exceeded our place because we only want to store 2 elements. So we are going to kick the 7 out and we are going to leave this as it is. Then we have value number 5. So once again this needs to be readjusted. So values are going to be 7 and then 5 and then 2, but once again we exceeded the number of inputs, so we will have to kick the 7 out. Now we only have value number 5 and 2. Once again we have value number 6, so 6 would come over here because this is a max heap. So we are following the property of descending order coming to the first, so the maximum value is going to be stored at the very top. And then once again we will have to kick the 6 out because we only wants to keep k is equal to 2 elements. Lastly we have value number 3. So once again first we will do the readjustment. So values are going to be 5, 3 and 2, but once again this 5 is excess, so this will also be kicked out. And then we are now done with all the values, and now we only have these two values inside our max heap. And the very first element inside the max heap has to be the kth closest element to the origin, and which we can see because this is the endpoint and the distance is square root of 3, and we can see that this is actually the second closest point to the origin after this one. So this is what we need to return as the answer, and this is the whole solution. So basically the important portion in this one is that first this problem looks complicated because we are dealing with like XY graphs, and I know many people after high school haven't even dealt with this one, plus you might have forgot about the Euclidean distance equation, but don't worry, these are all just the constant matter. So all we need to do is, number one, we are going to iterate over the given input, and we are going to find that what has been the Euclidean distance from every single point to the origin using a simple mathematical formula, that is x1 minus x2 square plus y1 minus y2 square and the square root of the whole thing. Okay, after doing this one, we simply need to initialize our max heap to the values or size of k, and we are simply going to do the operation that we just mentioned. In the end we can simply do max heap dot peak operation, and that is going to provide us the kth closest point to the origin, and that's it. This is the whole solution. So now if we see time and space complexity, in this case time complexity is actually going to be big O of n log n, because it takes log n time to enter values inside the heap, and we will have to do this n times. Plus we will also have to spend some time calculating the distance from the origin to that particular point, but that is going to be constant effort that needs to be done for n values. So we can simply ignore this one because it is no longer relevant, because we already have a higher time complexity component. Space complexity, once again we will have to create an extra heap, so that is going to be big O of k. So now let's try to see the coding solution for this one. So the coding solution is actually quite straightforward. We are first of all going to initialize our max heap, and inside the max heap we are going to store the values based on the distance from the origin to that particular element, and that is going to be done based on using the Euclidean distance formula from the origin. And once we have those values sorted, then all we need to do is just simply add those values inside our heap. Now inside the heap we will first add the value, then we will check that if the size of heap exceeds the value of k, we are going to poll the very last element we entered inside the heap, and that's it. Now in the end we simply need to collect the kth closest point from the heap. So for that we can simply create a result array, a 2D array, and we can simply run from I to the k, and we will try to find the element, and then we will poll it inside the result, and then we can simply return that as part of the result. So this is the whole solution. Now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared in terms of time complexity, and extremely good in terms of space complexity. So once again, the solution is present in our GitHub repository. So if you want, you can go ahead and check it out from there. Thank you.